Welcome back, everyone, to another episode of Cubane. So, last time we left off, we started by synthesizing all these compounds down to tribromoketal, and now we're going to synthesize the Diels outer product and also the dione. And then from there, we can continue on with the UV step and all that, but I'll talk about that at the end of the episode because there's more to discuss that I can't really fit in right now. But pretty much this is what we're going to do. So, yeah. For the Diels-Alder dimerization reaction, you reflux the tribromoketal in a solvent such as methanol or ethanol with sodium hydroxide for like 4 hours. It precipitates out sodium bromide. Now, an interesting thing is that I've actually done the same reaction before, but I tried to use isopropanol this time because I wanted to see if it works or not, and it just made tar. So I gave up. I remade some tribromoketal so I can do it the normal way using ethanol or methanol as a solvent. I used ethanol because I was out of methanol. So after doing the bromination, which you can see the setup is a bit large, so it didn't fit in the fume hood, but I still went ahead and vented it through a scrubber into the fume hood. Unlike someone, and I'm going to be petty because I am right, objectively, unironically, I am. So, I shall present to you this great PowerPoint I made, and I will be petty when it actually sort of makes sense, because someone calls me the worst chemist, even though they themselves don't even know how to store bromine properly. So, let's look at this nice PowerPoint presentation I made, and before Microsoft tries to download some spamware and bloatware on my computer, I'm going to turn this away because it's trying to dox me as well. Let's see. Why Frederick is the worst chemist I know. By me. Figure 1. That is how he stores bromine. I do not know who in their right mind stores bromine this way. And mind you, he is 1 year older than me, so he should have more experience. And also, during an argument, he argued that I have less like textbook knowledge, which textbook knowledge is not going to tell you how to store bromine properly. Well, it should still, because come on, polypropylene, are you serious? And the reason he did this is because he does not have a flask with Teflon. Which, mind you, you do not need a flask with Teflon or like any fancy polymer to store bromine. You can put it in a glass bottle with a glass lid and freeze it or put it under sulfuric acid. And this is what I mean about him like being a hypocrite, pretty much. I store in the worst possible way. Explain to me. But nice, use screenshots from other people. No, you posted this on your own server. You posted this on your own server. So yeah. And also, he apologized to me. He did not. So that's why. People who, they are actually critical of me for a valid reason, I'm fine with that. That makes sense because everyone makes mistakes and everyone needs feedback in order to improve. But really saying I'm the worst chemist and then you yourself storing bromine like this? I don't think I'm the worst one in the situation here. And here's how I store my bromine. So at first I stored it in a glass bottle like this, glass bottle under sulfuric acid with a glass stopper greased with sulfuric acid, which also had a glass sealed cap over that, so no fumes escaped. But that I've been storing it for like that for like a few years. But recently I got sent some Teflon lined lids, so I store in that now. Which before you say, oh Edward, that's not going to be very like durable. The discs are 1 millimeter thick Teflon lids. Thanks Jay for sending me them. He sent me some toluene as well. Teflon inside the lid. It's not expensive to get these, or to just store in a glass bottle under sulfuric acid. Yeah. The bromination. Do I have to explain why this is a bad idea? I mean, I presume he does not have pure dioxane in there, but rather a mixture of dioxane with dichloromethane. And now you will see in the bromination, it fumes a lot of HBr from pressure. So not only does he not have a pressure equalizing funnel, which how... Oh, also, before I say how are you supposed to add bromine in, I know how he adds bromine into it. He told me. He takes a stopper, removes it from the flask, the bromination flask, that is pouring out HBr gas, that is also water sensitive and will ruin your yields, and unstoppers this, and opens the funnel, which is also missing a handle there, so have fun trying to fiddle with that thing. And do I have to explain why putting a head clip on every single part of your apparatus is a bad idea? Though his thermometer adapter is duct taped in, so I guess it technically isn't sealed, at least not very well, but are you serious? It's not that expensive to get a thermometer adapter. Just the O-ring in it is pretty cheap. And even if you can't afford that, wrap Teflon tape around your thermometer and stuff it in. Even if you can't do that, get a piece of latex tubing, which yes, it will be single use, slip it over the thermometer adapter and put the thermometer through it. That's the old-fashioned way of putting a thermometer in. So, yeah. Do I need to explain? I mean, yes, I do, of course. So what you see here is him doing the dimerization step we're going to do shortly in this video. So this step, of course, involves a solvent such as methanol or ethanol and sodium hydroxide and the tribromo ketal, and you simply let it reflux very gently. For a reflux, you don't need it to be flowing super fast. Reflux means it's boiling. You don't need it to boil very fast. It's still going to be at the same temperature. So, I don't know how he messed this up. I didn't include a separate image where the heating mantle was glowing red at night, so I don't think I should have to say this, but for a reflux, especially of something like methanol or ethanol, which has a below 100 Celsius boiling point, you do not need to turn your heating mantle onto full power. That's not a good idea. Now, I think I know what happened here. So he set his heating mantle up to full power because he was impatient, and you can see here his condenser water line goes into a juice container, like a large juice bottle, and he has a water pump in there, and you can see condensate on the bottle. So I think what happened here is that he was pushing the reflux to like a very high speed boiling, and what happened there was the condenser water could not keep up because the water was getting hotter and hotter from the reflux, which is why you should always put ice in your refluxing water, or just to get a large container, or be like me and put a radiator in it so your water remains at room temperature. So what happened here was, not only is the reflux going super fast, but the condenser is no longer condensing anything. So all the methanol or ethanol evaporated, and he left up burning his product and also breaking his flask because hot sodium hydroxide in glassware is not a good idea. But yeah, I have never seen this happen to anyone. I haven't even done this. I don't know how you can do this. It's honestly amazing. And thank you for watching. So yeah, I will once again reiterate, I'm not against criticism. I'm open to reasonable criticism. Reasonable. Hula, I do not have money to buy pretty much a organic lab. I do not have money to buy, like, a fume hood. That's why I built one. That's the important thing. Reasonable criticism and reasonable expectations. This is home chemistry. I do not have a lot of money at my disposal. In fact, that's partly why I've been slowing down on the cubane synthesis. It's because I don't have money to keep up with the reactions and reagents and all the equipment that I need for it. So yeah, there you go. If you're going to criticize me, at least adhere to your own advice and also be reasonable. Thank you for watching. So yeah, let's go back to the actual cubane video. So here's the bromination. It's done. You can see all this HBr, and I left it overnight to finish brominating. Though in the future I might try a longer time. It's like, did the usual, put it in bicarb solution, wash it out thoroughly to get our tribromo ketal and dichloromethane dioxide mixture, and then I distill that off and added in some cold methanol and put it in my freezer to get our tribromo ketal out. You can see this time it's not the most pure, but it will suffice. So I set it up for the reaction, and I didn't record it because it's honestly so simple. You put the tribromo ketal in methanol or ethanol, add in sodium hydroxide, and let it reflux for like 4 to 6 hours. And you crash it out, you get forbidden coffee. Now I just simply filter it off, wash it a few times, and let it dry. And now we're going to do the double deprotection to the dione. So here is all of the what was it? Alright, Deal's outer product. So I weighed it out, and I ran out of sulfuric acid, at least 95% stuff. So I quickly distilled some 80% I had, and for fun, I put a hot dog in there to show you why hot sulfuric acid is not something you should play with. And this is why I don't recommend people distill sulfuric acid. And you don't have to distill it most of the time. Drain cleaner's already 90%. It's only this stuff I had was old and it slowly degraded down to 80%. So now we're going to go ahead and run deep protection. It's very simple. You simply let the sulfuric acid cool down and you slowly add in your Deal's outer product. And you can see here, his stir bar got stuck, so I stirred a little. And now it's been more than 24 hours, so I'm going to go ahead and let it crash out, and that should be done with deep protection. And deep protection does look horrible like tar because it is concentrated sulfuric acid with an organic compound, so that's a bit expected. And also because the ethylene glycol, the acetyl group that gets removed from it, tends to form dioxane as well, so it makes tar. So I'm simply going to pour this into some cold water, ideally ice water, but I didn't have any. And here's our dione precipitate. It is warm, of course, from the from the sulfuric acid in water. So I'm going to go ahead and rinse the flask out and dump that in as well. Okay, so after this, we're going to have to recrystallize. And now, unfortunately, I do not have ethyl acetate nor hexanes at this time. I would try to use heptane, but I don't have heptane either because I didn't buy any new cans of starting fluid to distill. So I'll be trying to recrystallize this from toluene, which hopefully works. Toluene, and I might add in something like methanol or ethanol to act as a polar solvent to make the thing more polar. I might also try acetone. Hopefully it doesn't react with acetone. I don't think it should. God, I really forgot how much I hate this filtering. Now, I'm not going to let this dry too long because the residual sulfuric acid will start eating out the paper and then it's going to become a mess. I guess I could just wash it again, though, because, I mean, I do have a Buchner funnel. I can use that to filter it, but I broke my 500 milliliter filter flask. I still have 250 ml ones, though, so I guess I can just wash it a few more times with water. Okay, let's do this. Paper towel, filtered paper, wet it with some water. And we're going to scoop our product into the filter. Looks like clay or mud. Forbidden chocolate. I mean, I guess I could make it work. Some got around the edges of the filter, of course. Okay, let's do it properly with 2 pieces of discount paper towel filter paper. So there's our 2 products. I think I'll let them dry on the oven, actually, because, I mean, they've been suction dry on a filter, so it's really just slightly damp now, so it's not going to dry properly on a piece of paper. Actually, I could just put it on my hot plate and set that to, like, 50 Celsius or something. And I'm going to go wash all this glassware and my hand. I think I can increase heating a little bit. I mean, what's going to harm it, really? I would use a fan to blow this, but I don't want to blow the dry powder everywhere, so I think I'll just move the fume hood sash down a little bit, increase the airflow across it. Okay, so our crude dione's dried now. It looks a bit charred. I don't think that's a good thing. But I'm going to try recrystallizing from dichloromethane. Now, the reason I'm choosing dichloromethane is because I checked the Cubane Bible for the various compounds and their data, and their physical data. And I found that one paper called for solvent as carbon tetrachloride. Now, if it's soluble in carbon tetrachloride, then it would have to be plausible that it's soluble in dichloromethane. However, the paper I'm following, the 1970s, the 70s one, I think. Is it the 70s one? I don't know. It's the Australian one. For the UV reaction, it calls for a solution in methanol. So I think I might be able to use a solution in isopropanol. So, I guess we could try it. Science spoon. I'm gonna have to buy another gallon of this soon. I'm gonna have to stock up on lunch.
Wow, I read it.
Wants to ban it. I'm already down to half a gallon. And I've been recycling it as much as I can, but this stuff evaporates far too easily. So we're gonna dissolve in some dichloromethane. Just a little. We get a brown solution. Nice. Let it stir. And turn on the heating and get it warmed up. And I'll add more dichloromethane as needed. Also gonna cover the beaker with something. I would use my beaker reflux condenser, but I'm too lazy to clamp it. this thing we made in a previous episode doesn't fit anyways. So I'll just place a flask over it or something. Where are my things? There we go. Wait, I have a 25. Whatever. This'll work. Okay, the dichloromethane, we're gonna add a bit more. There we go. And I'll cap it off, dichloromethane, and we'll just wait. It looks like it's all dissolved. Darn it. Oh, yeah. You know what? I don't need that. So, I'll just put it here, and I'll put it in the fridge after letting it cool down to room temperature. So here's what's left with butyl dichloromethane evaporate in the fridge. So yeah, you can see it's tar, but we have some crystals in there. So I think we do have our dione product. So now I'm going to try recrystallizing from toluene, which is actually the best solvent for this. Not really the best, but it's like the most convenient I have. So I'm simply going to boil some toluene here, and we're going to pour it in, and that's it. Again, thanks to Dre for sending me toluene. It's impossible to get in California, and also like the rest of the US now because, of course, EPA. So you can see it dissolves quite well in hot toluene, so I think this will be my solvent of choice for further crystallizations. Now, something interesting is that if you happen to heat the dione accidentally by spilling on a hot plate, it is a very potent tear gas lacrimator, and also irritates your skin and nose. So, yeah, don't sublime the dione. You're going to get tear gassed, which I learned on a separate run accidentally. Yeah, it was not fun. So you can see here I filtered the toluene solution off, and we're still left with quite a red solution, but you can see we got a lot of the tar out of it. So here's our dione solution. You can see some crystals forming already. So we're going to go ahead and let this evaporate and cool. And yeah, that's pretty much it. Now the red color is likely due to impurities, but again, they get separated out during the crystallization step. So that leads us to here today. All the previous footage you watched, aside from the slideshow, was from July of this year. So yeah, Cubane has really come to a halt because I don't have the money to keep funding it, unfortunately. So yeah, but here's our dione that we have collected, which is not a lot, but it is something. Now this is a separate, different run, and you can see I got bored and left it in the filter paper, and the acid sort of dissolved it. So I think we should be able to get this working again, but again, I'm not sure if I'm going to continue the cubane synthesis because it is very costly. Though, if there's enough interest, I will start a Patreon. The only thing is, on the Patreon, I will not be posting exclusive content such as, for example, like spicier syntheses or whatever. I don't like to paywall information. In fact, pretty much every single research paper I have read that is not free, I have pirated using Sci-Hub. So, it's just, in my opinion, it's not worth paywalling information. It's information, it should be free. There should be no reason it's hidden behind money. So, if I do make a Patreon, so if there's enough interest, or alternatively, I can open my PayPal for donations, but if I do make a Patreon, it will be specifically for posting raw footage of my reactions, because why not? And also because I do want to archive those somewhere, but I don't have enough storage to like just keep them on a hard drive, so might as well upload it somewhere. So if there's enough interest, I'll do that. But also of course maybe some not like exclusive chemistry stuff, but just like random ramblings or ideas or whatever. And of course you'll get videos earlier. But yeah, that's pretty much the end of this episode, and possibly the end of this series. Hopefully not. But yeah, see you guys in the next episode where we're gonna do something else.